that you see V naught is output voltage across the resistance RL. So you know from Ohm's law V is equal to I into R. So the current flowing through the circuit is I naught. So it's a simple single loop, right? So you can find what is I naught. So the only voltage what you have is Rm into Ii. You have two resistance in series, R naught and RL. So I can write I naught equal to V Rm Ii divided by R naught plus RL, V by R. I have two resistance in series, so add them. So Rm into Ia divided by R naught plus RL. So that is going to be my I naught. V naught is equal to I naught into RL. So see here, V naught equal to I naught into RL. Okay, so I naught is Rm Ii divided by R naught plus RL. And I'm replacing this term Rm into R naught divided by R naught plus RL by R capital M. So I'm writing V naught as R capital M into II. See, all these notations should be very familiar to you by now. So all notations are small suffix. For simplification, you will consider the big term as a single term with suffix capital. Okay, so that is the difference. Same way here also we are doing V naught is equal to capital RM into II. See here there is one mistake. It is RM II into RL. I am measuring V naught across RL. So it is RL will come in the numerator. It is given wrongly in the textbook. RM II RL by R naught plus RL. So RM into RL by R naught plus RL. Here also, here you will get RL. That is going to be R suffix capital M. Okay, now I can substitute this V naught in the KCL equation what I wrote here. So I'm substituting V naught value in the KCL equation. IS is equal to II plus beta into V naught. V naught is RM into IA. So IS equal to II plus beta into RM into IA. See, if you don't simplify this R capital M, you will have a very big term here. And all these terms are constant, right? See, Rm is constant, R naught is constant, RL is constant. So definitely this term will be constant. So I'm replacing that by a single term, R suffix capital M. So here you see I can take it out from the two terms as common. So II into 1 plus beta into Rf. So now the input resistance with feedback RIF is equal to VI by IS. Okay, the input resistance considering the source current IS. So VI by IS. So VI divided by IS, we have got a simplified term. So IS is 1 plus beta RM into II. You know, VI by II is RI. So RI by 1 plus beta into RM. So this is the input resistance of the amplifier with feedback. So you know that when you have voltage shunt feedback, input side la shunt. So whenever you see the term shunt in the input side, when resistance are in parallel, the resistor or the effective resistance or the equivalent resistance will decrease. So that is evident here. So Ra is the input resistance of an amplifier. Because of applying negative feedback, my input resistance becomes Ri by 1 plus beta into Rm. It is divided by a huge number. So effectively, I can say RIF is reducing. The input resistance of the amplifier after applying feedback is reducing a lot. So usually for an amplifier, we require the input resistance to be very, very high. But see here, the input resistance is very, very less. So this amplifier will draw more amount of current from the source. It will drain your source. So when you are using this voltage shunt configuration, you should be very careful that this amplifier should have proper input resistance to be controlled. Otherwise, it will draw more current from the source, and your source may get drained, and the amplifier will get damaged because of heavy current flow. Because when resistance is less, current flow will be high, right? So that may damage your transistor. So certain feedback types you have to be very, very careful, because see, our standard consideration is input resistance should be very high and output resistance should be very, very less. Okay, that is our consideration. But in certain amplifiers, the reverse may happen. Okay, the reverse may happen. So in that case, you should be very careful. And just a second. Okay, so in this amplifier, the input resistance is decreasing, which is not as per our requirement. So we have to be very, very careful when you are using this amplifier for your application.